Is this working? Wait, why isn't it? Oh, okay, I think it's working. Okay. So, yesterday I was just fiddling around with the circuit I had started drawing, which was going to be a counter. And as I was doing that, it threw, I'll show you, it threw an error. And so I just didn't touch it, I left it there, and now I'm going to try and figure out where that error came from. Unfortunately, I will probably just have to mess around until I can find the error, because I don't know exactly what caused it. But we're in the place obj function. Backtrace would have been useful here. There might be a way to get one, but I don't know how. So we create the port objects. Oh, we're in the loop for creating the port objects. If n, what's n? N. Oh, auto connects to adjacent neighboring gates or junctions. Okay. If n is component, then do all of this stuff. Else if it's a junction. Some port number stuff. This assert didn't fail. And then is the net. Oh, why does this say O? Wait a sec. N is the net object inside the junction. NN dot O. Yeah, what? I don't. Do nets have a dot O? Okay, what line is this? 341. Let's try and remember that. Now I want to see. When we create a new wire object, G and J. I mean it. Okay, all right, I have an idea. Let's just see if I can make this happen. So this was a case where we already had a junction and then we place a gate. Oh yeah. So it's got to be, this is probably supposed to be G. I probably just have a typo here and wrote O. I mean, don't ask me why. But let's actually check that that worked. So let's, oh no, we need to place the junction first. Those should be connected. We can check that. Yeah. Okay. So that was easy. Okay, we fixed our problem. It was just a typo. Now, the thing that we actually need to do today, I'm starting to have issues where with just the arrow keys and the two buttons, it's starting to get hard to do the things that I want. Like for example, if I want to do copy and paste, the obvious thing to do is make it another tool, right? But cycling through the tools and just looking at the text up there is not great for usability. So this tool menu, like it was, you know, the real idea here is that, you know, we want to have a, excuse me, we want to have a, like, you know, more useful tool select. Yo, today's sunrise is really impressive. Just a random thought. Why is it that sunrises look different from sunsets? Anyway, yeah. Because I want to do a copy and paste tool, or at least like a move tool. Having an undo stack would be really, really nice. An undo stack is really not easy. Because when we place a wire or erase a square or anything like that, it can change like dozens of objects. I'm thinking, maybe, so here's an idea. What if whenever we perform any action, anytime we edit any of our like objects, we write down how to undo it. So like if I delete something from a list, then what I would write down is put this thing in the list. If I edit a pointer, say inside the grid, I would have to write down, put whatever used to be there back. If I add a coordinate to a net, I would have to say remove it, but only remove it if it wasn't there before, because we can redundantly add coordinates, and that's fine. This is getting too complicated. I mean, what if we just deep copied? I mean, you know, deep copied everything. In theory, the only things you should have to copy are the grid and then those global tables of objects. You know, let's just try that. Let's just try that. Let's I'm looking for the, yeah, this menu item here. Let's do function I don't know what to call this. I'll call it snapshot. And we'll have undo stack equals blah. Now, if stat1 is greater than, I don't know, 1900, then let's just throw a big error message. Assert false out of. Wait, I don't need to do that. Pico 8 will do that. What am I doing? Okay. So now, yeah, just deep copy. Oh, this is not simple. This is not simple because whenever we copy something, we need to update whoever points to it to point to the new one. But we do have like double-edged pointers everywhere. Anytime one thing points to another thing, we can always follow it backwards. Okay, let's just start by deep copying just so I can see how much memory it uses. It's probably going to be like, well, I mean, it depends on how much stuff you have in your design. Whatever. Let's just start by deep copying grid and just seeing what that gives us. Well, nah. Yeah, I don't know. Local copy equals blah. For linear coordinate value in grid in pairs of grid to I really need a helper function here. Copy a table. If type of T does not equal table, then simply return T, else we will copy everything. We will do for KB pairs T do ret of K equals deep copy of V. This is an issue. This is going to be infinitely recursive. If you have a table, if you have like two tables that point to each other. So local copy let's just do this for now. And now we will do if v is equal, I don't know, but we can still, we really don't have a choice here. We need one of these. So v equals that. If, I see what we need to do. If not, yeah, I see, this will work. If not, if we don't have a copy of v, then copy of v equals deep copy of v, and now we can just do this. Okay, that should prevent the infinite loops. So just deep copy everything will figure out pointer updates later. This is just a test. So let me just look over this again and make sure that it makes sense here. If it's not a table, then just return it, that's fine. Otherwise, we have this copy table. I see. These should be shared. Equals copy or a fresh table, and we'll pass that in like that, so that they all use the same copy memo table. And I think this makes sense now. Yeah. Okay. Now, so copy.grid is equal to deep copy of grid. Copy.net is equal to deep copy. Oh, fascinating. Oh, very fascinating. So I'll rename the snap. Here's what I just realized. Check this out. I think actually, if we do this, this might actually just work. I mean, maybe. I mean, we'll see. Okay, do that. So we need gates and junctions. And then we will do undo stack equals an empty table, and undo stack, we can add, we can do in Pico. Wait, let me double check the manual there. You gotta do table.insert in regular Lua. Yep. So we will do add undo stack to snapshot. And when should we take a snapshot? Whenever we should take a snapshot whenever something changed. So in general here we will do local updated equals true, guilty until proven innocent for this particular case. And here we will do updated equals false, else updated equals false. So erasing definitely updates. Placing wire definitely updates. Placing a component definitely updates, but this doesn't. So now here we will do if updated, then what do I call it? Snapshot. Yeah. So first, let's just see if this, oh man. Let's just see like if this even works. So what's our memory? 114 kilobytes. Okay. Draw some wires. Okay, that's actually not too bad so far. I mean, if we limit the size of the undo stack, I think we'll be okay. 145. Can this even be real? This doesn't make sense. I think the undo stack isn't working. Oh no, it definitely is working. Okay, so one thing we need to do here, clearly, is that sometimes nothing happens. So we need to have a little bit of a smarter way of doing an undo stack, but that's okay. Now, maybe the way to do this is a different thing. So let's just have these functions return whether or not something updated. So now, all right, let's start with erase square. That should be a fairly easy one to deal with. All right, let's see. So this is one level of indent. Okay. So actually here we can return false. Nothing changed. Well, that nice sunrise is over. But all the rest of them need to return true, basically. Now we do have a recursive call to erase square, but it's okay, we can still return true. So now, at the very least, let's say I put down some wires like this. Now if I go in here and erase a blank, I think the memory used was only going up because it was adding to the log. So now, yeah. Okay, so now let's erase these wires. The log is throwing off the memory. Okay, this is 116.5098, and if I erase a wire, 116.5605, and then 116.6426, and if I keep erasing wires, yeah. So, okay, at least that much is working. If I erase all of that, 117. So all of that cost me a kilobyte. Okay. Now, I mean, if you really want to see the moment of truth, well, no, hold on. We still need to. So place obj always returns true, like, no matter what. Or like place component always returns true, because it always erases the square ahead of time, and whether or not something was erased, something would have changed. So actually over here we'll do this updated equals here, but actually here we can just straight up do updated equals true. For place wire, it's different. Sometimes if you place a wire on and nothing can happen sometimes if you place a wire. So we'll keep this, we'll edit place wire. Same thing over here. I don't know, place component, yeah. Yeah, okay. So now let's go edit place wire. So sometimes nothing can happen. And I think there's only one place where nothing can happen. So this is the wire-on-wire case. So here something does happen. Log no work. Great. Good thing I had that there, so I can do return false. Wire on gate. I don't expect this to happen so often. Well, no, because if you're holding down the button, well, whatever. You know, it doesn't have to be perfect. Well, but still though, if we put in a bunch of like duplicate entries into the undo stack, I mean, you know, let alone wasting memory, but it'll make it harder for the user to undo stuff. They'll have to undo the same thing like a dozen times. So if P is net neighbor, let's add a condition here. Connect net to port. So if port dot neighbor equals P, then already connected. Actually, let's make this a log. And we'll just return false. So this should prevent duplicate entries for this case. Actually, let's turn this log on. So in this case, we are just checking what's going on here. If we have a wire on wire, then we do all that. If it's a component, then we do all that. And then this is if it's blank. And if it's blank, then we always do something. And return true. Oh, what about this last W? Shoot. I think we have no choice. This is ugly. There's gotta be a better way. Well, hold on. Maybe there is a better way. Like this LWX, what's the last time I use it? I think the last time I use it is like all the way up here. So, oh yeah, this is at the top here. LWX. So I definitely use it there, and here, and there. But now I don't use it at all in any of the logic down here. So actually we can make this a little bit better. Okay. Oh, well, that definitely didn't work. Uh-huh. Why did that break everything? What? Oh, wait. What was this? I see. Okay. Okay, that's why. Okay, this should fix that. Okay, there. That's better. Okay, now. Let me think in my head here. I'll just keep drawing until I run out of memory while I think. While I think about if our current undo stack will actually work. For some reason, the scrolling is really laggy. I don't know why. When you're not scrolling, it's fine. Oh wait, everything's getting laggy. What's going on? Oh, saving everything in our undo stack is taking processor cycles. We're still like super low on memory. Yeah, so those deep copies are really expensive. Okay, well, that, like, already just, like, that already, like, invalidates this approach. You know, there is a way to fix this. There is a way to fix this. Sometimes when you are like editing something, like let's say you're editing like text in Notepad or whatever. Well, actually, Notepad, you can probably undo every single individual character stroke. But in a lot of editors, especially like if you Control Z something that you typed in your browser, um, it doesn't undo at the level of individual letters. It'll just be like, I don't exactly know what it does, but like if you type just one letter and then wait 10 seconds and hit undo, yes, it will delete just that one letter. But if within the span of a few seconds you type like 10 letters, then the undo will erase those 10 letters. In other words, there's like, if you do a bunch of actions really quickly, they'll all get grouped together into one like snapshot. So here's the idea. What we can do is exactly the same thing. People will think it's a feature, but it's actually for performance. Over here in the snapshot, what we will need to do is just like quit if we are running out of processor time. So what we need here is a budget. Budget equals I guess budget, or I don't know, how much should we give this, like 0.1 of a frame? No, how is this going to work? So I definitely need to give it a budget. Here's the rule. If we run out of time, then we should yield, right? We should yield, and yes, okay. Actually, this seems like something that would be useful as a library function, so I will write it that way for now. Is there a coroutine dot wrap in here? No. Wait, what is it called inside Pico 8? Oh, it's just called co-create. Can you kill a coroutine? Pico 8, because there is in Lua, there is like a coroutine.delete or something like that. Coroutine not close. Closes coroutine, that is, closes all its pending to be closed variables, which is a Lua 5.4 thing, and puts the coroutine in a dead state. The given coroutine must be dead or suspended. In case of error, either the original error that stopped the coroutine or errors in closing methods, returns false plus the error object. Otherwise returns true. Yeah, well, that doesn't exist in Pico 8. Yeah, otherwise I think we just need to like let the garbage collector handle it. I think there's no other choice. Now, I was just thinking, like, say I have a long running function. There is no way to like asynchronously interrupt it. Like, in other words, in my function I need to check if I'm out of time. Once I get this once, we'll be okay. So okay, I think shoot. Because checking for the time, it's just going to make an already slow function slower. There is no other option. Okay, I have a slightly different idea. Let's do DL for deadline. DL. And here what we will do is if stat, what's the stat here for the processor time? To view the CPU load while the cartridge is running, print out stat1. Yes. So if stat1 is greater than or equal to deadline, then we hit our deadline, missed our deadline. Now we will do DL is equal to co-yield. We just yield. Okay, and we need to yield false. Otherwise, here we return true. Wait, no. Ah, that's why the memory wasn't creeping up. I need to return ret. Yeah. No wonder the memory wasn't creeping up. So if we missed our deadline, and the copy should be the last argument. And what happens if I do like 2 greater than nil? It'll throw an error. Okay, if 2 is greater than nil, then int I. Yeah. So you have to pass this. You have to pass this. Whatever. That's just the rule. You have to pass it. I mean, to do a conditional at the start of this function, I mean, the function is already slow because of having to call the stat1 and do the comparison. Now, you know what? You have to give it, okay? That's just the rule. And I'm going to call this like deep copy DL. Deep copy with a deadline. You must give it a deadline time. You must pass a table or copy. This can just be bleh if you don't care about it. You know, when I first started programming, okay, I never once, or maybe once or twice, but I almost never cared about making like super generalizable functions that could handle any kind of scenario, any kind of input, any this, any that. I never used to do that. And I was writing programs, and they were working. And then over time, I don't know, it got instilled in me, you know, oh no, this is good practice or whatever, and you start to run into the problem where instead of writing functions for your own use, you're writing library functions. And the thing about library functions is that you're trading off performance for generality. I mean, so sometimes the language can help you not trade off performance. Like for example, although it can be quite miserable to use and understand, in C++ you can do crazy things with like templates and function overloading and default parameters. And that can help you not lose performance, but you still pay a price, which is that you're using all this like terrible Sphene stuff in your code, or whatever the concepts do nowadays. I've never used concepts in C++, but they really don't look friendly. Yeah, so what I'm trying to get at here is, like this function, I was originally going to write it as a library function, but why bother? You know, case 1, I only ever use it in this code. Fine, I don't need to make it generalized. Case 2, I want to use this function again. Then I will copy and paste it and make whatever tweaks I need for whatever other project I want. And that's what I used to do, and that was fine. You know, I'm not linking against a shared library here, and I have to worry about people. You know, like, no, I'm not doing that. Like this is just like I'm putting a function in a program, and that's it. So yeah. Anyway, rant over. Yeah, rant over. Yeah. Now, let's do local deadline is equal to stat1. Let's give this a 1/10 of a frame. it's kind of arbitrary. Let's just call this DL. This is deep copy DL. I'm starting to get annoyed with the length of my variable names. And okay. Now, what we need here is, I don't know, we need CRT is equal to, I don't know, none, I guess. What's the best way to do this here? So in the update function, I will eventually call this snapshot. Okay, I have a better idea. So let's call this start snapshot. Or we will do CRT equals, I guess, right? So now this snapshot, and we'll call it start snapshot. And we'll actually take the deadline as an argument. And now we will do we're doing all kinds of closure stuff here, but local thing to do is going to be a function. We're just going to do all of this. And now here we will return true. Now we will do return co-create of thing to do. Shoot. This is annoying because this is going to use the DL that it grabs from the closure. And although let's say we get halfway through this second deep copy, then we do a yield. And when we resume, we're going to pass the new deadline. That's the reason why I'm doing DL equals yield here, because when you resume a coroutine, whatever arguments you pass to the resume call get returned from the yield call. So we can get a new deadline like that. The problem is this is only going to edit, actually I didn't realize, but this is actually going to be a problem for the recursive calls as well. This is only going to edit the local DL in this call, not even like the lower, well, I guess it does get passed into the lower calls, but it won't edit it in, well, actually it's okay if it doesn't edit it into whoever called this function because they've already checked the deadline and they've already started. So actually this would have worked anyway. But we need a way to edit the up value. I actually don't know if there's a way to do that in Lua. Like if you can reach up in your closure. It's got to be in here somewhere. When a C function, oh no, that's in the C API. Okay, what if I was just Control F-ing the Lua reference manual for up value. I'm not showing my browser window right now. That's okay. What if okay. This is something I just need to try. I just need to try it. It's too hard even to explain. So let me pull this up. Oh, dude, why is that so small? Oh, that's why. Okay, let me do that. And then let me do this. And let me increase the font size here. Okay, I don't know, closure test. So we will have function, I don't know, make closure, function some, I don't know, let's call this print x. Print x equals string of x. Return function. We will call print x inside here. And actually what we can do is if type of x is number, then we can increment it just for the heck of it. I mean, I think I have been swearing in these videos, but I shouldn't. I would rather not. So we'll print that twice. And now let's do f is equal to make closure of 7, say, and then we will call f. Nil both times. So, oh yeah, actually I don't even know why I needed to pass this as an argument. So yeah, this, I don't know, what if I do local x equals x? I doubt that would make a difference. Whoops, come on. Still nil both times. Okay, now what if I do, well, obviously in here, even if I delete this line, in here, if I do print in return function x equals, so obviously here, it'll print 7, I think. Whoops. Yeah. So, what's the rule here? The rules for closures are very slippery, at least to me. I mean, I'm sure like all the people who've been writing Lisp since day one or whatever have no trouble with it, but you know. How come my cursor is a line and not a block? Anyway, so here, so is I mean, okay, let's read this out of the reference manual. Why not? It's worth knowing anyway. A function definition is an executable expression whose value is type function. When Lua precompiles a chunk, all its function bodies are precompiled too, but they are not created yet. Then whenever Lua executes the function definition, the function is instantiated or closed. This function instance or closure is the final value of the expression. It's at the moment of the creation of the function that all of the variables are, all of the of values are figured out. So yeah, this was never going to work. Let me think about this for a second. Oh, duh. What am I doing? Let's just call this D. Do D.dl. Just pass it as a table. Or D of 1. Just like, you know, whatever. Here we'll just pass D. And then in here, we'll just wrap it like that. There. Okay, problem solved. It's a little, well, I kind of want to make this a shorter name so that it fits. Deep copy, whatever, it's good enough. I'll know what it means. And actually, we can do even better. Put it, that also lets me put a comment here. Wrap deadline in a table so function calls can edit it. This is passed by reference. And then here we can just do D, so I can at least put the the spaces back. You'll have to forgive me, a lot of the time in these streams is me just like trying to make the code nice. So I think we can fit the Y back. There, that's pretty good. Then we can rename this. Let's do strictly greater than. And okay, if we missed our deadline, then we yield, but we do allow this coroutine to be called again. And okay, here's a question. What happens if I do co-status of nil? Runtime error. Co-status of 7. Runtime error. Okay. C equals co-create of f costatus c suspended. Is it co-resume? Dead. Okay. Okay, so. Oh, here's something else I've been meaning to try. So just get rid of all this. I figured out what I needed. Oops. Function f. We will do print before x equals. This should edit a global. Yeah, that does edit a global. Now, oh shoot, you weren't even seeing that. I may as well show it. Wait, how come? Man, OBS is a little wonky sometimes. Okay, this is what I just ran. So here I have a function that sets the variable x to 7, even though x is not defined anywhere, and then I just called the function twice, and the results were the first time we call it, it's nil, the second time it's 7. So yeah. Now, one thing I've been wondering about is what happens if I just do local x like that? Does that even compile, or like, you know what I mean? Oh, fascinating. Now, one thing I was wondering is if you have a closure, the scope of a local variable begins at the first statement after its declaration and lasts until the non-void statement. So, what happens if it's probably just defaults to global. Yeah, whatever. I'll just assume it defaults to global. It's a pretty safe assumption. Okay, now, where was I? I was in the middle of doing this. So here we are now passing this by reference. If we missed our deadline, then we yield. Okay, great. So starting the snapshot, we have to give it a deadline. So CRT equals nil, I guess. Start snapshot. This is our function. We create that as a coroutine. This is kind of expensive, but it's fine. Like we didn't have to make this a local function that creates a closure. We could have made this whatever. It's fine. Okay, it's fine. So this creates the coroutine, and when we resume it, it doesn't take any arguments. It already knows what to do. And at the very end, it'll add to the undo snack. Okay, and we may as well yield false here for convenience. Okay. So now here, we are starting the snapshot, but now we actually need to run the snapshot. Oh, shoot. The states are going to be all garbled, won't they? Uh, I mean, shoot. This is terrible. Ugh. Shoot. Okay, this is not pretty, but the states only matter for this, right? So first of all, let's put this first. Actually, let's put the grid last. I don't know why, but that just feels like the right thing to do. And now here what we will do is we need a global here, which is skip tick. Now here we will do skip tick equals true, and then here we will do skip tick equals false. And also in the start snapshot, we will always put skip tick to false. In case we set it to true and it resumed here, or it yielded here, and then we started a new snapshot. Now what we will do is, remind me how we did that? Update net. Then if fnum equals 1, oh man, what is this fnum? I forget how that works. Update if sims, yeah. So actually this skip tick, where is that defined? Up here, good. So and not skip tick. And then down here, where's update state? If fnum equals 1, we're going to do this like that, and not skip tick, then Okay. And now finally, when it comes time to do the snapshot, we will do should that be in the update function or the draw function? I think it should be in the draw function. Or maybe in the update. Yeah, I think actually maybe it should be in the update. And actually, like, updating the state and all that would also make sense in the update function, but the problem is I want to do that after we draw stuff, which is why it's in the draw function. But yeah, let's do it up here. So now there is a case where I think we can return early. Yeah, right up here. So let's just arbitrarily just go here and do if CRT and co-status CRT then local DL is equal to stat1 plus 0.1, and we will do co-resume CRT with deadline. Now this co-status, I forget exactly what it returns. Let me check the Pico 8 manual. Co-status. Okay, so we will just say does not equal dead, and type of C should be thread. Yeah. Okay. If type of CRT equals thread and it is not dead, continue copying state for the undo stack. Do you think this is going to work? So let's also do assert let's just, for our sanity here, do assert co-status of CRT does not equal running, just for sanity. Okay. Oh my goodness. Unexpected symbol. If type of CRT equals thread. Oh. And it is not dead. Okay, so far no performance problems. Let's check the memory. I guess it's fine. I don't know. Keep doing some stuff. Fascinating. This is using about 300 bytes every time. I don't. You can't tell because I have the debug stuff open, but I'm just like drawing stuff. Okay, the performance is still okay. Now, what remains to be seen is whether this undo stack actually works. Although the performance is creeping up here. Why is it... Who's taking all this time? Oh, we're good on memory. Yeah, who's taking up all this time? Is it the post conditions? I bet you it's the post conditions. Actually, let's add that in. Oh, I needed an extra space. Okay. So if I just draw some wires. Performance is good so far. It is still creeping up, most likely because of the post conditions, which we'll check here. Oh man, performance is really creeping up. Oh yeah, it's all because of this post condition here. That's okay, that's fine. But our memory is pretty good. We didn't have any performance problems because of the table. Or not because of the deep copy, I mean. Now, the big question is, does this undo stack actually work? Right now, I've just been trying to like test for performance and stuff. You know what? I just had a thought. This deep copy of the gates where everything's frozen should actually be last, so that we spend the least amount of time, because a bunch of stuff is going to be memoized, right? Same thing is true here for the grids. If we memoize the nets... Oh, shoot. Oh, shoot. Yeah, there's no choice. We do have to do it first because these nets point to the gates, and if we deep copy the gate at this point in time, yeah, this really does have to be first. There's no choice. That's okay. That's fine. Let me do the comment for myself. Must do components first because nets point to components and we might deep copy them early. Now, let's think about this. Is it the case that in this deep copy scheme I have going on here, is it the case that the pointers will be updated to point to the new tables? No, absolutely not. Definitely not. Beyond the shadow of a doubt, definitely not. Because, like, let's say I take a grid square, for example. Well, no, actually, would this work? Maybe it's better just to try it and see. Because I do this. Yeah, and maybe this would work. All right, let's do function do undo. If size of undo stack equals 0, then we'll just log undo stack empty. And just return. Otherwise, we will do local copy is equal to undo stack of, so okay, local n is equal to length of undo stack, if n equals 0, return. Local copy is equal to undo stack of n, undo stack of n equals nil, grid equals copy dot grid, nets equals copy dot nets, gates equals copy dot gates. We can put more stuff in the undo stack. Like, for example, the cursor position or the selected tool, but for now this is fine. Junctions equals copy dot junctions. Okay. Do you think this will work? Oh, we need a way to actually call this do undo. So how does that menu item function work again? Menu item. There's no way this is going to work, but I kind of want to see how it fails. Menu item 2, the label is going to be undo, and the callback is going to be do undo. Draw a wire, draw another wire, draw another wire. Well, that didn't work. Actually, one thing we should do here, log, so if type of CRT is thread and code status of CRT does not equal dead, then wait for it to finish. So actually, we'll do this. While that do resume CRT with a deadline of like 5 or whatever. Do coroutines get interrupted by an update call? That would be cool, actually. That would be really cool. Anyway, we'll see what happens. Any running copies finish. Assert is not equal to running. Okay. So yeah, for some reason this isn't working. Log time to undo. Number undos equals n. Oh. And any currently. Of course that isn't working. Running copies. We'll just straight up do CRT equals nil. Get out of here. And what we need is we need to do n minus 1, because the thing we're copying is the current state. So if we undo and just go back to the current state, you know. But that should have popped it, though. Well, anyway, if there's only one element in the undo stack, it is the current state. I see the problem. It was not the state before we did the change. No, we just have to do this if n is less than 2, and we'll just arbitrarily do this. Like, we'll just ignore, you know. Undo stack of n minus 1. Okay, let's put down a wire, put down another wire, put down another wire. Undo. Undo stack empty. Whatever. It's just a log message. I don't need to. Okay, so if I do this. Oh, right. Number of undos equals 0. Why isn't that? Whoops. Shoot. Okay. Now we will do log adding to undo stack. Fascinating. Why isn't that happening? We will do resumed copy. What? Log started copy. Log copy gates, or I guess components. Log copy nets. Log copy junctions. Maybe I just don't know how to use coroutines or something. Is that what's going on here? Started copy. Copy components. What's? What? What's going on here? How come? All right. This is ridiculous. Debug. Type of CRT equals that. Whatever, this doesn't have to be pretty. Debug CRT.status is type of CRT is nil. Okay. Now let's place a single wire. Type of CRT is thread. CRT.status equals dead. Started copy, copy components, and then it just ends? What? I wonder. If this is the problem. Ah, there we go. I see. It threw an error. Attempt to compare nil with number. Okay, well, that's not super helpful, but it's probably this, which is the problem, if I had to guess. Why did I put this do undo in such an annoying place? I want it here. So local D is equal to table with just the deadline in it. And we pass that table in to all of them. Start snapshot. Oh, I needed to do this. And yeah, that's why. Okay. Well, we got something else. Attempts to call global deep copy. Where? Where? Line 400. Where's my cursor? Oh, right here. I think I just have the wrong function name somewhere. Oh, right here in the recursive call. All right, I think we're making progress now. Okay, no errors. Draw some wires. And let's try undoing. Well, it didn't work. Global grid, nil value. Yikes. So this do undo is probably not quite right. Copy is take that element. Isn't that what I called it? S.grid is equal to deep copy. Why is that nil? Oh, wait a sec. This shouldn't be there. It should be here. Okay. Do that, do that, do that. Moment of truth. Well, it still doesn't work. Attempt to index local O. Oh, I see. Oh, fascinating. Right. Fascinating. Oops. Okay. Whoa, dude. Okay, so I think I'm out of what's in my log here. Whoa, dude. Is this working? Like, what the heck? So what if, okay, let's say I was just editing something and, you know, it's like, oops, oh no, I accidentally connected these two nets. I didn't mean to do that. Oh, yo, I cannot believe, I mean, it probably doesn't work completely. And it's also a little inconvenient to use the undo from the pause menu. I'll bet it doesn't quite work. So this, okay, this pause menu's in, or this performance menu's in the way. So let's, you know, do, I don't know, put in some stuff, just play around with it, and maybe something like, actually, out of memory, yeah. So what we need to do is cull entries from the undo stack if it gets to be too big. We should also support redo. Okay, I got an idea. You know how when we have single step mode, it goes into like a special mode where you can't edit anything, but when you press the arrow keys or any button at all, it'll just step the sim. We should do that too. We can go into undo mode, and then we'll have like left arrow key and down arrow key will undo, and then up arrow key or right arrow key will redo. We can even have Z and X. Z is pretty typical for undo, and then I guess because X is the only other key, that'll be redo. So that's what we'll do. First of all, we need to fix this memory problem. Now what we will do is shoot, let me think about this. I guess we'll do while stat, what is it for memory, 0? Whoops. Yeah, stat 0. So while stat 0 is greater than, I don't know, 1536. And length of undo stack is greater than 1, greater than 2. Greater than 1, greater than 0. Yeah, whatever. Log needs to call old undos. Delete del I, undo stack 1. Let me just double check how del I works. Yeah. Yeah. Let's just draw some stuff. Whoops. Performance is good. The post condition is what's eating up most of the performance, so I'm not worried about that. I definitely want to implement that undo mode, undo redo mode. I'll do that in a second. So yeah, performance is good here. We're not running out of memory. Let me check what the memory is. Yeah, great. We're keeping it bounded. Yeah, good. Yeah, the performance is going up drastically now that because of the post condition, but that's okay. Oops. Yeah, good. I think that trick is working. So we're almost done implementing the undo stack. The last thing I want to do, I got to remind myself how I did the single step mode. I did it as kind of a special case, but now I'm going to have another special case here, but I don't need this anymore. Quit early if in single mode. Oh, this is not the right function. Okay, so now I go down here, draw helper stub, draw grid, draw G menu. Here we go. Local modester equals blah and single, otherwise modes of mode. This is annoying. I got to do two things. First of all, actually, I need to do three things. First of all, I need to edit this drawing so that it actually shows undo in the corner. Second, I also need to prevent sim ticks. And then third, I need to hook up the buttons. So yeah, first let's do this. I don't expect to have any more special cases than single step mode and undo mode. So I guess it's okay to just put it in as a spaghetti of if stuff. So if undo mode, then modester equals undo redo, else if sim speed equals 0, then modester equals single. Okay, so that's step one is done. Step two, we will do and not undo mode. Okay, step three is hook up the buttons. Well, there's more to it than that, because to support redo, I need to not delete the elements from the table. And I also need to edit the menu item function. So yeah, this is going to take a while. Yeah. Quit early if in single mode. Or undo mode. So over here in do undo, actually what I want to do is, oh man, okay. So for the undo stack, I also want to have undo pause equals 1. And in here, instead of just adding it, we will do undo pause plus equals 1, undo stack of undo pause equals S. No, like this. And now here, instead of this, well, I'll leave this behind, but I need a function here, which is just going to go with the menu item here, which is, so actually, I don't even need to make this a hardcore, like, so I'll call this toggle undo mode, and actually I may as well do this function. So undo mode equals false, function set undo mode. If I go in here, do that. This is kind of a hack, but undo mode equals not undo mode. And here we will do undo mode and leave undo or start undo. And I'll call this toggle. And I'll do this, but I'll also do this. Okay. And the last thing to do is to hook up the buttons. How did I do that? Oh. Man, this is getting to be really ugly. I mean, truly, really ugly. if undo mode local u is equal to button push and 0x. What's the order? So undo is going to be left or down or Z. So that is 1, 9 is greater than 0. And 1. Actually, I don't need that. Local R is equal to, what the heck? Oh, I forgot the B. Button push and 0x, the rest of it. So that is 26 greater than 0. Is that right? Yeah, I think that makes sense. If you, then we will do undo, else if R, then do redo. Actually, okay, so now here we will do, I don't know what to call this. It's like movement or motion or I don't know what to call this. Frames? Amount? Let's just call it X. Well, V. No. I don't know what to call this. Let's call it M. Why not? Well, N makes sense. And here we can do len. Actually, here we will do if not undo stack of undo pause plus n. So maybe I'll call this off. So undo pause plus off. I can just do n. And then here, copy is whatever is at n. We will not erase anything. Now this is actually going to be part of that toggle undo mode function. Because in order to redo, we'd need to, yeah, so let me just do that now while I'm thinking about it. Well, no, I have unfinished work in here, so copy, and we need to reset the undo pause. We'll do undo pause equals n. Okay. Now, here's where things get a little weird. Maybe not weird, but badly organized. Where's my do undo? I know, I need my toggle undo mode. If not undo mode, then let any running copies finish. No. Shoot, I wrote this code. I made the exact same mistake when I first wrote this code. Do while do co-resume CRT like 5. Entering undo mode, let any running copies finish. Here for sanity we will assert that it is not currently running. Okay, now here, leaving undo mode, delete anything in undo stack. Past undo pause. To do only delete when a new edit is made. Yeah, I mean, why not? We can do that. That's super easy. Maybe I'll do this. Start snapshot. And then right in here, deleting invalid redo history for I equals undo pause plus 1 up to the length of undo stack of I equals nil. Oh, shoot, I think I have an off by 1 error, because here I'm doing that. Shoot, so this undo pause, it is the position of the current state. So actually we do want to do it like that, and we want to start it at 0. And Yeah. So the very first time we save something, it'll go to 1, and we can only move it to a valid index, and we only ever call do undo with either +1 or -1. And we make sure, yeah, I think this works. There'll probably be some syntax errors for me to fix. Yeah. Unclosed function toggle undo mode. If blah then, if blah then. Oh. Okay, we fixed the syntax errors. Now, whether or not this works is a different story. Draw some wires. Okay, let's enter the undo mode. Oh, it's moving the cursor. But it does work. We can redo. Okay, so I just need to make sure it doesn't move the cursor. Yeah, actually this works. It's a little slow, but cool. And if we leave this mode and enter it again, we can still redo. But if we leave this mode and then make a change, we can't redo it. Oh, wait, what was that? Okay, there's some kind of bug here, but the first thing I want to fix is that I don't want to move the cursor. How does that work in the single mode? Okay, dumb hack to prevent moving cursor in single and undo modes. If undo mode or sim speed is 0, val equals 0. So that should prevent that at least. Blah, 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 blah. We do have to fix some indexing errors in our undo stack. Yeah, it would also be nice Oh, interesting. I happened to just barely hit the last one there. It would also be nice if it didn't draw the cursor, but that's okay. I don't really mind that. Okay, now let's see if we can recreate that bug. Ah, I was just able to recreate it there. All right, let's try and do a simpler one here. So, let's put in 3 wires like that. Enter the undo mode, erase 1, leave the undo mode, place another, and now browse to the undo redo mode. Okay, something is definitely messed up here. Oh man, this is going to be tough to debug. But after I debug this, then the undo redo mode is basically ready to go. Well, that may not be true because I still haven't tested that undoing and redoing like gate connections and all those like really nitty gritty little stupid junction rules. I still haven't tested that that works properly, but it might. Who knows? Okay, I really need to figure out this problem though. So it's almost certainly like an off by one thing with the undo pause. I'm just trying to think of what I should log and what I should debug in the log view to help me figure this out. Okay, let's go in here into, where's my do undo function? Oh my goodness, I think I have caps lock on. Do undo. So we have the length of the stack, and let's also log undo pause equals undo pause. We will do log deleting undo entry I, log creating undo entry undo pause. Okay, so this edits the undo pause. The only other thing that edits the undo pause is this do undo function. So let's also do a log new undo pause equals undo pause. All right, let's see if we can figure it out with just this. So we will do 3 wires like that again. We will enter the undo mode, erase 1 wire, leave the undo mode, and put in another wire like that. Now, actually before we do anything else, let's look at the log. I should get rid of all those copy statements. I really don't need them anymore. Anyway, I'll leave it for now. Creating undo entry 1, that's the first net. Creating undo entry 2, or the second wire, you know, create undo entry 3. Number of undos equals 3, time to undo, new undo pause equals 2. Then we create a new net. Now this actually should have erased undo entry 3. Oh yeah. Deleting undo entry 3, creating undo entry 3. So this replaced undo entry 3. Deleting invalid read history, creating undo entry 4. So far this seems right to me. So now if I undo, it should be what it was before. And if I undo again, uh-oh. All right, now we need to check the log. New undo pause equals 2. Now why is that happening? let's do a couple of things. Okay, first of all, let's get rid of those unnecessary log messages from deep copy. Oh no, not from there, but from here. But I'll comment them out. It might be useful if I'm debugging performance problems later. That's fine. We definitely want to keep this, although I don't need that. That's unnecessary. I also don't need that. It's redundant with the other log message. And let's also, just to keep my sanity here, way to turn off log messages while I debug something else. Okay. Oh, I guess I will keep started copy. Created undo entry 1, 2, and 3. Now, if I go in here and undo it, number of undos equals 3, the pause is 3, time to undo, new undo, pause equals 2. All of that makes sense. But now, if I draw any wire, like even over here, I should have put a separator. I'll put one now. Deleting undo entry 3, creating undo entry 3. Yeah. So far that makes sense. So now if I enter the undo mode, and I undo that, what? Okay, hold on. Oh man, I have no idea what's going on here right now. This message is also bothering me. The start copy message is bothering me. So let's not even connect the wires. Let's try and eliminate that from the problem. Oops, so I want creating the entries. Okay, if I now go in here, I undo. So the new undo pause is 2. We also set the grid on everything. Or did we? Wait, let me take a look at that function for a second. And yeah, so far that looks good. And this is a really tricky one here. So now let's put in a separator, right? We'll enter the undo mode again. Oh wait, no, I don't want to do that. Let's put in another wire, like down here. So now if I go in here, deleted undo entry 3, created undo entry 3. Put in a separator. So now I'm going to enter the undo mode. I'm only going to hit it once. And let me watch what happens in here when I do that. I'm going to hit it once. Undo pause equals 3. Time to undo. New undo pause equals 2. Okay. So why didn't that do anything? I wonder if this is like a really like, it's like a pointer thing, you know, like when we copy, I was worried about that from the very beginning. It's the kind of thing where it's like, oh well, yeah, maybe it'll be useful to turn on dump nets. It'll make it a little bit harder to read, but here's my dump nets. I think it's commented out right now. I think this will help. Let's try this again. So I don't need a performance window. So put a wire here, a wire here, a wire here. So they're all around here. Let's put a separator in. In case you didn't watch when I coded up this log here, the separator, all the keys I'm using to enter my blue debug mode screen, scrolling up and down, adding separators into the log, that's all using the player 1 controls. Everything else I'm doing with the player 0 controls. Yeah, okay. So now what? Yeah, okay. Now let's undo and see what happens. Just hit that once. Go back in here and see what's going on. So the nets look correct. Let's put in a separator. Everything looks correct so far. It's surprising to me that we haven't hit any post conditions, by the way. Now let's place a new wire, like down here, somewhere totally off the wall, so we can see it. Now if I go in here, the net dump looks good. Deleting undo entry 3, creating undo entry 3. So now if we undo, we haven't touched undo entry 2. But what I'm worried about is that undo entry 2, you know, it has, you know, it's pointing to like a grid object, and it's pointing to a nets object and all that. I wonder if, oh, yeah. Oh, I see the problem. I just realized the problem. Over here in the do undo, we need to do a deep copy. Or do we? No, we shouldn't have to do a deep copy. Yes, we do. No. Yeah, man, this is tricky. Yeah, we do need to do a deep copy. So yeah, I'm just going to do like a regular deep copy function. I really like, you know, oh, why do I have this twice? Regular deep copy. And whatever, local copy equals copy or an empty table. Don't need to do that. Actually, we'll still keep that. Must pass table for copy and use blah if So I don't care how long this takes. Regular deep copy. Whoops. So that should fix that problem, I think. And we didn't hit any post conditions because everything we were doing was maintaining all of my invariants. It's just that I was editing the wrong copy of the snapshot. Yeah. I think this works. We don't care how long this takes. We do not care. So now that should fix that problem. If I do this, this, and that, I undo one. Okay. Oh yeah, right. This needs to call the right one. So if I do this, that, and that, and I undo, come on. What the heck? Oh, right. So where's that set meta table? We've got a whole bunch of calls to set meta table. So actually, I don't want to do this here. I will do it in the other one. Okay. There, that should fix that. Oh. Okay. Bam, bam, bam. Undo one of them. Put in a new wire. Yeah. For some reason I can't undo that last one. Ah, I see. Under init, I need to start a snapshot for the blank one. Or do I? I mean, they're all empty tables. So what we'll do here is we will do undo stack of one dot grid equals empty table nets gates Sorry, I got something in my eye. Okay, junctions, undo pos equals 1. That should help with, oh, what did I do? Oh, yeah, okay, fine. Do stack of 1, like that. Actually, we can do a little bit better. Alright, so now we can do this. We can go into the undo mode and undo it all the way back to a blank canvas. And we can leave the undo mode. We can redo a bunch of stuff. We can draw new wires, and now we shouldn't see any. Yeah, good, done. Mission accomplished. I can't believe we did it. Alright, let's gut punch this. Oh, one thing I should do though before that, we do have an, how come that wasn't in my to-do? Well, anyway, we have an undo stack. And it works, I guess, maybe. We'll see. I'm sure we'll run into bugs with it at some point. Bring up undo support, git push. The shame here is that all this trouble I've done to like deep copy everything, which granted wasn't that hard. The deep copying itself was actually pretty easy. The hard part was dealing with performance. But that doesn't really help me for saving and loading, which is the other big feature I need to support. Well, saving is dead simple. I just save the whole grid. Right now I don't have any extra metadata to save, although I did have that idea that because I'm actually only using 128 tiles, I have an extra bit in every single grid square at my disposal. And there was another section, oh yeah, the flags, the tile flags. That gives me about, I think it was like 1100 kilobytes or something, or sorry, 1100 bytes to work with, so that I could put like text labels or stuff. Text labels and stuff. It's or something and stuff, not or stuff. Anyway, yeah. I'm debating whether I want to keep working on this right now because I'm kind of on a roll here, but I don't know if I have enough. What time is it? Oh my goodness, how long have I been here? Oh my goodness, I've been working on this for almost 3 hours. Yeah, I wanted to go for a bike ride today while it's like warm out, or warm enough out. And I am worried that if I start on another like big thing, I'll just get sucked into it and be tired and then never go out for that bike ride. And yeah, so that's what I'll do. Let me see if there's a small thing. I'm not doing this right now. I'm not even really sure like what it should look like. I did this. This is done. Well, I mean, it's not really done. I only have the I components. I don't have any O components. O components would be interesting if we could do something cool with that, like, you know, have the user draw something on a frame buffer, or have it play sound or something like that. Oh man, copy and paste. That's going to be another tricky one. Although it will be a lot easier once I write the saving and loading. That's probably why I put it lower down here in the to-do list. It's starting to come back to me. Because once I write the function that can read from like the saved tile data and then, you know, then put together all the nets and stuff again, then copying and pasting can just use that. Yeah. This, I don't know if I'll ever do it. I'm not really sure I want to. Okay, here's something we can do. Let's, at least while the implementation is fresh in our head for the like the undo stack. Let's actually try and do like a little circuit here. I want to try doing that. I want to try doing that counter. Whoa, whoa, whoa. Okay, something has gone desperately wrong here. Okay. I think we've had some kind of infinite recursion problem, most likely to do with the deep copy. Oh yeah, missed our deadline. Yeah, we have an infinite loop in the deep copy. Shoot. I knew this kind of thing would happen. Let's think about it, try and understand. So the problem is that this deep copy on the value, maybe through several, it finds a table in there, and then eventually it ends up calling deep copy on this same t, the original t. I don't understand though, because this memo table, the whole point of it was to prevent. Maybe I need to do this. Which means I don't need to do that. T. Oh, wait. Oh, shoot. I see. I think I see the problem. The key can also be a table. Shoot. No. Okay. One second. Let's just put it back the way it was for a minute. And let's first just try doing assert that K is not a table. Let's start with that. Yeah, so that's not the problem. So, where is that infinite? How can that be possible? Because okay, well, let's try that thing. let's try that thing. Does this even work? Like, let's just try that test case again. Whoops. Okay. Okay. I doubt this will fix anything. Yeah, we have the same problem. I didn't think it would fix anything either, and I prefer it like this, so we'll put it back since it didn't fix it. Why? Oh, why, oh, why, oh, why, oh, why, oh, why? There's no choice here. There's no easy way for me to put like a log message and like debug it that way. I just need to think about what's going on. This is a case where, you know, I'll bet this happens also if you like automatically plug a gate into another gate, like if I do this. Yeah. So here what happens? Well, when we place the second gate, we automatically connect it to the first one. So what we have is a situation where we have two gate objects. They each have 4 port objects, and the 2 port objects point to each other. I gotta draw this out here. I need to draw this out. So let's go over here. No, not like that. Like this, right? Yeah. Okay, and let's go into here. So what do we have going on here? We have one, we have one gate object, and inside there are 4 port objects, which I'm only going to draw one of them. And I believe this port object points to that port object. This port object points to that port object. I think that's the way it is. So when we do a deep copy, let's say we do a deep copy, we come in on this gate object over here. Let me change the color of the stroke. Let's say we come in over here. We'll do a deep copy on all the keys and values. We notice that this value is a table. So we do a deep copy on all its keys and values. We go over here, we notice this value is a table. We do a deep copy on all its keys and values. We notice that this value is a table. And now here is where I expect the memoization to prevent the infinite loop. Oh, I get it. Okay, I get it. Because we only write it into the memo table after we're done deep copying it. But here this is in progress of being deep copied. That's the issue. Oh man, how on earth do we fix that? How on earth do we fix that? So I think here what we need to do else, we will do copy of t is an empty table. Local, I'll call it tc for t copy, equals copy of t, just for convenience. man. So I think. Oh no. We want this. We want this. Copy of t equals ret. Like that. Like that. Like that. Like that. Like that. I think this will fix it. I think that's all we needed. Let me put a comment here. Subtle. And still get infinite recursion without this. I can't think of a short way to write this in text, but I think this works. I think this works. Yeah, I think that did it. So, okay, great. We fixed one problem. So let's make ourselves a nice little clock. And then I will do my little trick there to get a pulse generator out of it, which I forget how I did that. I want this output to be 0, only if they're both 0. So like this, I think, is what I need. Yeah, there. So there's my pulse generator. So let's first do like a little shift register to try and keep things simple. Whatever, I think you get the point here. This is kind of ugly. Cool. Yeah, so we have a shift register. Now these essentially act as flip-flops because it's hard to explain. Like a latch with a very short enable time is pretty much functionally the same as a rising edge sensitive clock, if that makes any sense. So yeah, now how do we make a counter? That's not easy. I haven't even used undo at all, but I'm only trying to use it when I need it. Or like, that's not what I mean. Like I'm trying to use it the way like a normal person would use it while editing. So, all right, let me think about this. So I need to have an input for count enable. And what are my current counter values? Well, let's just put them in like this. Should I let's put them vertically for now, even though I think I'll probably regret that. Now, how did that summer circuit work that I had? So if this is the carry in, and then this is just the value that we're adding to, then, geez, I really need to think about this. I need to take their XOR for the sum, which I will do so I need, so one way to do XOR is A and B or not A and not B. Sorry, what I just said now is, here, I should write it out since I have the drawing tool open. So so like A XOR B is equal to not, which I guess I could just write like this, not AB or not A, not B. I think you get the idea. This font is a little hard to read, but there, that's good. So A XOR B is not AB or not A or not B. The reason I am writing it like this is because I want to use this AB for the, well, I need this for the carry output, right? So, okay, I need an AND gate, which is just all nots, like that. And now I need a NOR, oh, not a NOR, it's like a, not a, oh no, no, this is a NOR, isn't it? Not A and not B is equal to the NOR, yeah, actually. So actually that's just this. And I think I need to do this. Like that. So now the AND is down here, right? And now the XOR is the NOR of these two things, like that, I think. Let me just try this with my inputs here. 1 plus, or 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 2. Good. Okay, so we can replace that with our latch. This is why I figured I would, okay, let me move that over here. I figured I was going to regret putting it vertically because of the clock. Let's start with a 3-bit counter. Seems good enough to me. So now, this is count enable. This is the new value up here, and this is the carry out down here. Actually, okay, I think it'll be easier to do this horizontally. So actually, the carry, oh, that's kind of annoying. The carry out is on, oh, I can fix that. I want the carry out to be on the same side every time. So I can do that like this and like that. Okay. Oh, did I mess something up? Oh, yeah, of course. So this needs to be that. And this needs to be this. Okay, so now the carry out is on top, and the next value is down here. Okay, I think that works. Okay, good. So now we just need to do the exact same thing over here, I think. Then we'll have a 3-bit counter. Oh, I need a little more space, actually. Oh, wait a second. Yeah. So, man, it would really be nice to have copy and paste, but, well, you can't always get what you want, I suppose. So let's do that. Oh, no, I need... So like this. So this wires into 2 gates. So here we'll grab this. Then down here we put 2 NOR gates. The NOR gate is by far like my most used gate whenever I'm messing around in here. Okay, now we wire this into both, we wire that into both, we wire this down here. The new carry out is up. No! Shoot. That's so unfortunate. Man, okay, hold on. Let me take a screenshot of this just so that I don't have to rethink about all this from scratch. That's annoying. Okay, I took a screenshot there. I'll review it later if I need to. Or actually, here, I got a better idea. Take a snip and just paste it in my XCaliDraw there. That way we can all look at it. Out of memory. Shoot. Why? I can't really think of anything to do but just draw this second half of the circuit over here and just see if I can get it to happen again. I wasn't even doing any like erasing or anything. So here we need 2 NOR gates. Up here we need this. What kind of gate is this? This is an AND gate, actually. That's just an AND gate. Yeah. Oh. I see. I know exactly what happened. I was just thinking about it. Over here where we call entries, we also need to undo pause equals undo pause -1. Because this, yeah. Wait, no. Wait a second. I think what we need to do is this. We actually don't need to do that. Like this. No, shoot. I think actually this was fine the way it was, like that. So I can just do -1 here, because this is Pico 8, not regular Lua. Okay, so I don't need dump nets right now. So let's take that out. What would help is if I had a way to detect infinite recursion. Okay, here's something really cheesy we can do. Oh, no, I know what the problem is. Wait, no, it can't be this because I'm not calling this function, although I do need to apply this fix to the other one as well. Okay, let's just start drawing. Let's just start drawing this. And keeping an eye on the memory used, I guess. I think I had like 5 or 6 of these. And then here I needed this, I think it was, yeah. So this is my clock pulse, which I'll just do like that. And actually, I can avoid some junctions if I invert all that. So, okay, first, before I do anything, let me take a look. Oh, I also want to turn off this simulation here. So the memory is definitely increasing. Okay, hold on. Before I get into it, okay. I'm starting to get pretty good at this. Whoops. Okay. This will be my clock pulse. Now, we're up to 840 kilobytes. Don't ask me why it's fluctuating like that. I'm not really sure why. It's a little strange, actually. That shouldn't happen. But I guess it's okay. Now, if I think. So I'm gonna invert, and when I say invert, I mean flip this upside down. So if I put in this like that, so this needs to wire into 2 gates. We'll put the 2 NOT gates here. We'll put the AND gate here. And, oh yeah, we need a junction here. And our count input will be this. Okay. And, oh yeah, actually I do need the junction anyway. It's fine, I'll just put it here. I should probably take a look at the memory, and let's also just put that there. Oops. Oh, here's a good chance to undo something. No! Oh, this is terrible. Yeah. Shoot. This is in the post condition. Oh my god. Else if n dot type does not apply. So that should at least fix that. Now we've got to do it all again. I mean, come hell or high water. Sorry, I guess, I mean, you know, hell is not really the worst swear word on earth, but by hook or by crook, I will draw a counter. Oh man. Oh my goodness. Oh my goodness. Oh my god. What happened? Have I just not tried to undo anything with gates? I think I just didn't test it thoroughly enough. I think we have a lot of problems. We have a lot of problems. Okay, let's just try a simple 2 gates back to back. Okay, so that's fine. Whoops. Oh. Oh no. Everything's wrong. Okay, I need a simpler test case. I need a simpler test case. I think it happens if I undo connecting a wire to a gate. Okay, can I do it even simpler than that? No, that doesn't cause it. Okay, I think the simplest test case I can find is this one. Gate 1, port 1, unrequited love, which I believe was, I couldn't think of a better error message, and I think that means if you have 2 gates back to back that aren't connected by a net, but they're connected because they're like adjacent to each other, if the ports don't point to each other, that's what that message means. And then here, port 3 is just pointing to nil, so Why? Now, does this happen with nets? What happens if I undo this? Oh, that's bad too. Net 1 points to gate -1. The gate is not in the gate list? The gate is not in the gate list. Why? How can that be? I need to think about this. So the net is pointing to some old, no longer valid gate object. Oh. I see the problem. Is that assert statement still there on deep copy? Oh, that's in here. Yeah, I know exactly what the problem is. I know exactly what the problem is. And I need to do the same fix down here, which actually would be easier if I do it like this. That should fix it. Well, I don't know if it'll fix everything. Where is this? Net 1 points to just like something garbage, but gate wrong. Still haven't fixed it. I thought for sure this would fix it. Oh, Wait a second. I mean, this is just gonna copy like numbers. There's really no point. Well, I mean, it's okay. I don't have like too many like just like arbitrary numbers here. I'm not really that worried about it, come to think of it. But still, though, how come? Man, I don't understand. Let's see if I can see anything useful in the log. No, there's nothing useful in here. Do I really have no choice but to add a bunch of print statements into my deep copy function? That would be horrendous. At least, I think if you're using Lua on a computer, you can at least get the pointer to the table. I can't even get the pointer here, which makes it really hard for me to see what's going on. Net 1 points to gate, just some non-existent gate, but gate is wrong. And then gate 1 points to the net, but okay, let's think about it then. The net has a net.g field, okay, and so G is just, okay, let's just do this real quick. Equals G, then log high, just to see. That's strange. How come that when it did the copy, what? This is an issue because different tables can have the same key. Okay. If type K equals table, then we will do this, and we will do K equals copy of K. And actually, we can do the same thing over here. If type T equals table, then not T, V. So that should prevent like filling up this copy with a bunch of random crap. It's a little annoying that we have this if statement when we also have it here. So actually, let's just go right ahead and say, if you are deep copying something that's not a table, you are using this function wrong. Okay. We'll do the same thing up here. And if type of K is table, then do that. And if type of V is table, then let's also just do that. It's a little easier to read anyway. Oh, wait, was this there before? Whatever. Okay. Now, let's try this test case again. I doubt this will have fixed it. I'm not really sure why it would have fixed it. I mean, this was wrong to always copy the key, because if it wasn't a table, like, we would use the same string, you know what I mean? Because like all the nets have a string, or have a key, which is the string G, a G string, no, have a string called G as a key, or no, anyway, you know what I mean. And it would have been wrong to do that. Well, no, it wouldn't have. Like, well, it wouldn't. No, it actually wasn't wrong. Now that I think about it, because the copy of the string would have just returned that string. But anyway, this prevents filling up that copy table with a bunch of extra stuff. So I guess it's okay. We'll just leave it for now. We'll just leave it for now. So we're still back to square one, which is why is the gates not being copied correctly? So let's try that again. Where's that? I got rid of it over here. Let's go over here and do if K is G, then I guess that's just something you can do in the console window. How come that's not getting hit? Because at the very least, any newly created net should have an empty G table in it, right? You see that? So why doesn't it? That doesn't make any sense. If I just place a single wire, it says creating undo entry. But that should, did I do that in the right function? Yeah, this is in deep copy DL, which is the one getting called. All right. Whatever, I'm just gonna do it. Oh, I put print, what am I doing? It should be log. There, now it should print. Yeah, okay. Now we should get it twice. How come we only get it once? Oh, because there's only one net object, of course. But now we should get it twice. And we do. Okay, so we are getting into the G table. So man, I can't think of a good way to like add debug statements here. I'm just gonna have to reason about it. If we have a net object and inside of it is a table G that points to, you know, some gate object over here. So this is the gate, this is the net, this is G, I guess, and there's a pointer in here that points to some gate. Now that gate is a table, so and it should be happening here. And in fact, okay. Let's do log copying key. So this won't say it. Now, how come that isn't doing anything? Oh, maybe because log key is table. Okay, so that is happening. We aren't decopying it because I guess we already copied it. So the net is pointing to just something bogus. This doesn't need, I mean, I'm just trying to get a handle on what's going on. Else. Table K already has copied V. Whatever, I'm just trying to understand. Table K already has copied V, and why are we getting that 5 times? Oh, wait. Yeah. Oops. Key is table. Key is table. Key is table. But type of V is not table. So let's just get rid of this, get rid of that, get rid of this. If key is table, then log V for table K is string. Yeah, that makes sense. Okay. So we do ret of K equals V. Also, this isn't strictly speaking necessary. Oh, man. Okay, 1 second. Okay. Man, this is tough. Does anyone know the answer to this? No one's even watching. That's okay. I'm not expecting people to watch. What am I not seeing here? Port. Oh, the port doesn't have a parent pointer. And so we never copy the gate. Is that what's going on? think that's what's happening. Man, that is really, really tricky. No, I do have the parent. Let me just, while I'm thinking about it though, make sure that the junction has a pointer back up to the parent. Oh, actually, I might have had to do it down here. Oh yeah, I did do it down here, yeah. So, okay, the parent pointer is there. So man, I cannot figure this out. Why? So, okay, so this is actually not an accurate picture. Let's at least redraw the picture before I give up for now. It doesn't actually point to the gate. Instead, it points to a port within the gate, and the port actually points up to its gate, among other things. And let me also take a look at the function there that actually does the snapshot. The very first thing it does is the gates. So it comes in here, it finds this gate, copies it, and it finds its port, copies it. Now this port does have a neighbor, so I guess I need to draw that in. Port does have a neighbor that points to this net. So then we go to copy the net. Then we go into the G and we copy the key. And this port should already exist. I don't understand. How can... All right, let me take another closer look here at, oops. Oh, well that worked. Why did that work? Oh, maybe because there was no, I get it, because there was no wire object to be incorrect. So now if I do, in fact, I wonder if I erase something down here. Yeah, that breaks it too, fascinating. So what exactly is the issue here? Net 1 points to a non-existent gate. So let's go over here in post condition and just double check how we're... So check net to ports. For every port, if the neighbor of that port does not equal n, is this a situation where we're taking the snapshot at an inopportune moment? Because remember, this is a post condition, and we should only be taking the snapshot when all the post conditions are satisfied, but it is possible for the invariance to be broken in the middle of the loop. Is this a case where the snapshot is just taken at a bad time? I don't see how that's the case. I don't see how that could be the case. Where are we taking this snapshot anyway? Let's not worry about that. Well, we'll check that later. So it's in here inside the update function. Oh, that's exactly why. That's exactly why, because oh, no. We started down here because there was an update. And at this point when we started, everything's been fixed. Like everything is good, so I don't think that's the issue here. I don't think that's the issue. Whoops. Let's get rid of these log statements. And let's just go for broke here. Let's just log everything and read it in the log. Log. Actually, we'll only do that if it's always a table. So t.type equals, and let's put a little marker here to show that we're entering the function. I don't like that. Where's the home? Oh, here it is. Okay. Now what will we do? Type k equals table log k dot type equals here we do else. You know what? Why do that? Oh, no, yeah, we'll do this. Log k equals k. I didn't want to do this, but now we are. So there you go. Whoa, what's going on with the indentation here? Oh, it's just from pasting it. Alright, this is not going to be pretty. We'll have to do a lot of hard thinking to understand what's going on. Oh, man. Missed our deadline. How the heck did we miss a deadline? T.type equals nil. T.type equals table. What? Oh my god. What's going on here? Something's wrong. Something's wrong. This is not helping. This is not helping at all. This is why I didn't want to do this. Don't ask me how we missed our deadline, by the way. That doesn't make sense, but let's put down just one component. What do we got? Key equals type, v equals blank. How come there's no, oh, because it got truncated, because it's just so long. I didn't want to do this. I didn't want to do this. But we're going to increase the log size. Man, even that's not long enough. K83, K84, K85. What the heck is all this? Oh, this is the lookup table. We don't need to be copying the lookup table. Oh my god. And we missed our deadline too. Okay, we need a hack. We need a hack for this. Some things shouldn't be copied. This is horrible. This is so horrible. Man, I've really stepped in it here. Then if, oh geez. Can we do string dot match here? Test equals 1, 2, 3, 4. Test match 1, 2, 3. Does that work? I guess we don't have a string compare, do we? Oh, do we at least have sub, string dot sub? There we go. This is terrible. This is terrible. Oh, wait. Okay, I have a better idea. I have a much better idea. Where's all my lookup value, lookup tables? Movement LUT. Oops. I want to check something here. Yeah, didn't think so. I don't really care. I mean, I don't even think these. Here's what I'm going to do. Where are all those LUTs? Man, this is getting to be a nightmare. Gate LUT dot no copy equals true. Wait, this is the rule. And then regla dot no copy equals true. If not copy of v, then if v dot no copy, then copy of v equals v, else decopy it. And we will do the same thing in the other one. I guess we can do the same thing here. It's starting to be a problem here to have two very similar functions that need to be kept in sync. But whatever, I guess. Okay, that should help a little bit. Okay, so type equals nil because the first thing we copy is the gate table. Key equals 1, type is a gate. That makes sense. Now, we deep copy the gate. T.type equals gate. Makes sense. K equals let. Fine, we don't copy that. So K equals C, that's the coordinate. K equals type, it's a gate. K equals port, V.type equals nil. That's not right. Oh no, port is a table. Yeah, it's a list. Yeah, so that's okay. So port 1. Oh boy, state 0, type port number 1, neighbor is blank. Go to copy blank. Just a bunch of stuff. How come key to type port? I don't understand that. But whatever, let's keep going. Oh, no, now we've left. Okay. To make this easier to read, I do need a done. So I do need a log. Just like, what's the opposite of a house? Whatever, let's just put the face because it's funny. So that'll make it a little easier to read. Okay, blank. Now, God, this is really shoot. I had something sitting on my desk and I just knocked it off. Okay. Anybody in chat know the answer? No, I'm on my own. So, so that's the gate list. Key equals 1, it's a gate. Now we deep copy the gate. Coordinate is component. Lookup value base. Key equals port. So, okay, and that's a table. So now we go into the port table. Key equals 1, it's a port. We copy the port. Neighbor is blank. Copy blank. done. Go back up. So we just copied the neighbor, but now we're still copying the port. Type port, state 0, num1, done. K equals 2, port, neighbor, blank. Type is port, state 0, num2, done. K equals 3. Neighbor, blank, type port, state 0, num3, k equals 4. Neighbor, blank, type port, state 0, num4, done the gate, right? No, done the port. Now the let, and don't copy that. Now we're done the gate, we're done the gate table, the nets table, then the junctions table is nothing, then finally the grid. And we do, excuse me, the grid. Don't ask me why the type of grid is table. That I don't understand. But anyway, we have a gate at coordinate 260 in the grid, and that's all. Now, let's put in a separator. And very carefully add a wire. And wow, we totally overflowed the log. This is miserable. There's really no choice. There's really no choice. How do we miss the deadline when there's like 2 things? Oh. This is horrible. There's no choice. There's no choice. I cannot think of any other possible thing I can do other than just like crank this guy way up. Just go for it. So I already checked this, right? So did all that. I added some separators. Now let's add a wire. Try and find our separators. Okay. Gates, type is gate. All of this stuff. Go into the ports list. Key equals 1, type equals port. Connected to blank. Also copy blank, done that. Key equals 2, port, blank, done. 3. Now this is where we should go and copy the net. So type equals port, num3, type port, state 0, neighbor net. Copy the net. For the coordinates, it is a table. Yeah, okay. Yeah. Set 259 to true. So we are done copying the coordinates table. Type is net. Now, for G, we go into a table. Whoa, what? Type is net. Now G is a table, it's just a list. Now we deep copy that list. And, oh, I see. We put an entry in that list, which is a port object. The key is a port object, and we map it to true, and then we're done. And then state is 0, we make an empty table J, and then we're done. Now we do port 4, then we're done the gates. Oh, we're done the ports of the gate. Now we finish the gate. Now we're done the gates table. We do the nets table. K equals 1, type equals net, but it's already copied. Empty junctions table. So this looks fine. So what's the issue? I don't understand. It appears to me as though the saved pointer in the nets G table is pointing to the right thing. That would be my guess. So why isn't it? At least we didn't miss our deadline. Don't ask me how that happened before. Oh, the blank object. The blank object. Well, it's the same. No, we copied it. Oh. Okay. I don't think this will fix the problem, but it is something that should help. Type equals blank. State equals 0, and no copy equals true. That should help a little. I don't think that'll fix it though. Let's just see what happens. Yeah, still wrong. Why? I don't understand. When we're copying the port object, we go and copy the net, and then we go into its G table, and then we have it point to the port. Like, I don't understand. The only thing I can do is just get more information. And let's just go nuts here. Let's just crank it way up. We got memory, we can do it. Put this down. Connect to, oh shoot, I forgot to put the separator. Put this down. Put in a few separators. Connect the wire. Check it again. Key equals 3. Type port num3 neighbor net. Now we copy the net. Coordinate is a table. 389 is true in that table. Done. State is 0. G is a table. Go into that table. Port memoized. So that should be fine. Actually, when we're copying the port, how come we're not copying the parent? Do we not have parents in the port objects? But we should though. Key 1, type port. Num1, neighbor blank, state 0, type port. How come there's no parent object here? So here we do set okay, well, so this isn't junctions, so I'm a little bit less concerned about it, but I'll check it anyway while I'm here. I say I'm less concerned about it because it's not the thing I'm fixing right now, although it does need to be correct. So ns is equal to j dot port. Oh yeah, that's fine. Yeah, this is fine. But what I don't understand, parent equals G. Is this just nil or something? Oh, parent equals O. What the heck? G wasn't even defined here. I think that'll fix the problem. Yeah, no wonder. Now if I go in here and I undo it, still wrong. Put in the component, put in some separators, put in the wire, look at the log. That's the gate table. Dude, I'm so confused how this is possible. Now we're doing the port table. Key 1 is a port. Need to copy that. Neighbor is blank. Parent is a gate. The gate is memoized. Type is port num1, state 0. That's strange. The blank... Oh, the blank is no copy. Yeah, that's why. Wait, did I do that right? Derp copy. How did I do the no copy case? If it doesn't exist, do it. I see. That's why we didn't get any prints. Yeah, that's good. That's fine. So, key 1, type port, neighbor blank. It is a no copy. Parent is the gate is memoized. That's fine. Type is blank is memoized at this point. Gate is memoized. Now we get in here. Neighbor is a net. Need to copy the net. J is an empty table, nothing in the table. C is a table that has 260 set to true. G is a table, go in here. Port memoized V true. I don't understand. I mean, this should be right. State 0. I don't understand. Somehow it's pointing to the wrong port object? I don't get it. I don't understand.
how could it be? Because it's using the memoization table. And when we first encounter that port object, we immediately put the reference to it in the memoization table. So the fact that it comes out as memoized, right? Where are we doing that? Not there. G, type equals port memoized. V equals true. Maybe there's a different way to do this. Actually, one thing worth checking, just double checking anyway, is that this other deep copy function is in sync with it, right? Here's something interesting. I wonder if this is something to do with it. We're overwriting it, right? So let's make sure that we're not like losing something. No, that's not the issue. We may as well leave that assert statement in. Oh, wait, what? What? What was that doing there? I think if that's not the issue, it was definitely an issue. Am I doing the same stupid thing up here? No. Wow, that was it. That was the whole problem. Wow. Well, at least we fixed it. All right, let's get rid of all these stupid log statements. I'm just going to delete them. Well, no, okay, before I delete them. So before I delete them, I'll push it so that I can get them back in. We need to do this no copy case in the other one. Unless, maybe we already did it, I can't remember. Oh, we did do it. Actually, let me also turn the log back down to something reasonable. Everything's fine. Good. Okay. Git add launch that. Okay. Oh, I guess you didn't see me doing the git commands because I forgot to change my OBS. I think it's all right. I think you've seen me do enough git commands that. Yeah. Now. Can I finally draw this counter? Is that going to happen? I don't know if you can see that on the OBS actually, but this is a pulsing wire, like it pulses once in a while. Okay, now let's draw some stuff. And this will be our count enable, which actually I will put here. So now I need my two NOR gates here. I need my AND gate here. Junction here, connect all this together. This some output wires back into here. Okay, so now we should have a 1-bit counter. Oh, this is probably something I should fix. Great, we have a 1-bit counter. Pat ourselves on the back. Oh wait, did that? Yeah, this is the sum. It's the value of the counter is actually this right here. This is the value of the counter down here, so. Okay, great. Let's draw the next bit of the counter. We need a junction. Put R2. Well, I finally have a working counter. Oops. Okay, this is a good time. I really hope this doesn't break. Finally. Great, so now we can wire this to that. And this should be a 2-bit counter. Hey, we did it. I finally drew a counter in my logic simulator. It only took 50 hours, however long I've been working on this. That's pretty cool, actually. Should we put a 3rd bit in? Why not? Let's just go for it. I don't need quite as much space in between them.
dude. The undo is so good. I mean, I desperately needed an undo. It was unfathomable to do like big projects and stuff without the undo. Ah, dude, check it out. This is a counter. So cool. I guess I could speed up the clock a little. Wait, sorry, wait, did something just go wrong? I wasn't paying attention. 1, 2, 3, 4, 5, 6, 7. Yeah, that's fine. Yeah. Okay, well, save. And let's make it, let's see. So this has, man, what's the logic delay on this circuit? I want to think about that for a second. The logic delay, or like the max delay, or the critical path, there, that's the word I was looking for. The critical path is 1, 2, 3, 4. Critical path is 4. So we could get away with a clock that pulses once every 4 ticks. Is that right? Okay. So how many ticks is this? This is 1. Yeah, actually, I think this is the absolute fastest I can make it count. Yeah, and if I try to make it any faster, sorry for the flashing, by the way. So if I try to make this any faster, like even 1 cycle faster, it won't count properly. Hold on, let's slow this down here. 2, 3, 4, 5, oh, 6, 7, and looks like it's working. That's interesting. Okay, I can slow it down a little bit here. That's strange. Actually, what is the... Okay, hold on. Let's put it in the single mode here. So I'm going to count the... Okay, so the clock strikes. So now we need... I was under the impression we would need 4 cycles to settle. So 1, 2, 3, 4, 5, 6. Aha. So we are actually... Oh, because this... I see. I see. No, don't want to reset. Let's put the speed to something not too crazy. Yeah, so this... so this... How do I put this? This pulse detector, or this pulse generator here, the period of this clock is not 2 plus 1, right? Because this is a delay of 2, this is a delay of 1. It's not 2 plus 1. The period is actually 2 times that, because there's 2 states that it cycles through, on and off. So actually, I think this will still work, even if I have a single cycle, or even if it's exactly 4 cycles. I think it should still work. Oh no, it doesn't. This is where it breaks. Yeah, because here we haven't we haven't satisfied the setup time. Just for your information, for this, if you want to do static timing analysis, right, you take a look at all your flops, you follow the D input of the flop, and then you count. Okay, static timing analysis, the basic calculation occurs first between two flops, or like you have n flops in your design, and you have n squared pairs of flops. Well, actually, there's some formula because no, you have n squared pairs of flops. So for every single one of those n squared pairs of flops, you do the following. Look at the first flop, follow its D input, and take the longest combinational path between its D input of the first flop you're checking all the way to the Q output of the second flop you're checking, right? So because I drew the circuit, I know that the critical path is going to be from this flop all the way to this flop. So let's just see that, right? So we follow the combo path back from the D input of this flop, right? So we have 1, 2, 3, 4. Yeah. So we have a combo delay of 4 between this flop's Q output, right, and this flop's Q or D input. But that's not the whole story. We actually need to check, does that time, those 4 delays, exceed the amount of time between ticks to these two flops? So actually, we can make this circuit work right now just by adding a single cycle of delay here, and now everything should work. See that? Now this bit updates 1 cycle after all the others because we delayed its clock by 1 cycle. This is known as clock borrowing or clock skew, where you intentionally delay the clock going to one of your flops to let your combo path have a little bit of extra time to settle on its value before we before we clock the flop. Yeah, so anyway, I'm really pleased that in this simulator, it's a really nice way to play around and see these concepts of setup time and like demonstrate things about hold time. So by adding this delay, by adding this delay, we were able to make this counter tick even faster, with now the disadvantage that these signals are now out of sync. These two signals update on 1 cycle. And when I say cycle, I mean sim tick. So these 2 cycles update on 1 sim tick. These two, I'm flubbing all of my words here. These 2 bits of the counter update on 1 sim tick, but this only updates on the next sim tick. So if you were going to plug this bus into something that uses the count value, you would have to understand that this value here is only valid a little bit after these ones, right? And you would play further tricks of clock borrowing. In fact, I think we could make this counter circuit go even faster if we put a delay rate here. Now, just for our sanity, let's do this. So what I'm doing here, actually, I don't want to do that. What I'm doing here is I am going to delay these outputs so that our final count value is all visible in one place. So this is our count value here. So how do I put this? Because I have 2 delays on the clock going to this flop right here, that means that this output of the flop is only valid 2 sim ticks, or like a delay of 2 after this flop over here, because its clock is delayed by 2 ticks, right? But what I can do is I can take the output of this flop and delay it by 2.
So even though this updates 2 cycles earlier, I take its output and delay it by 2, so now it's at the same time as the output of this flop. What I've done here is I've done more clock borrowing, which has let me, I'll do it here in a second, but now that I've done this clock borrowing, now the critical path is different, right? Because here, although the combo path from this D input to the flop going all the way back to this Q output of that flop, it's still 4, right? But now we have given ourselves a margin, an extra margin of 2 ticks by delaying the clock to this flop. So before, when the clocks were the same, we needed to make sure that there were at least 4 ticks in between clock pulses for this value out here to settle into this Q input. But now we've given it 2 extra ticks to work with. So now the clock pulses can be only 2 ticks apart and everything's fine. And I don't know if this will work. I might have an off by 1 in my thinking here. But this may actually work. Yeah, you see? So now what we've done is we've made a really fast counter. Well, for loose definitions of really fast. So that if you only look at these 3 bits down here, right, and just look at these. Here, let's just do that. So now we have a count. And if I put the speed back to 1, this is a really fast count. I mean, with enough diligence, you may be able to have it count even faster. Like if you played really clever tricks with the clock borrowing, you might be able to get this to update on every sim tick and be a good count value, but yeah. Yeah, you can see this is really, really, really ticking over here. Actually, I want to check something. This is ticking on every frame, so actually, what I can do, sorry for the flashing, although luckily OBS doesn't capture the flashing that well, so that kind of saves your eyes. Yeah, so this should still work. Let me slow it down here so I can see what's going on. Yeah, this works. So this is it might be possible to have this update on every tick of the simulator. That I would really have to think hard about how to do it. Actually, I think I can do it. I think I would just get rid of the flops. I wouldn't even have a clock. I think that's the only way I could make it tick on every single like sim tick. Like have the clock count on every sim tick. But for a clocked design, like a counter that actually uses flops, this is the absolute fastest you can do in this simulator. Yeah, and the trick is to use clock borrowing. So yeah, okay, good. I'm gonna go out for a bike ride. Let me save this. It would have been nice to be able to save and load, but it's okay. It's saved into YouTube video for all eternity. So actually, do we even have any diffs? No, we don't. So there's nothing to push. I was just messing around. Yeah. Cool. Yeah, we'll end the stream.